Okay, in this video, we're going to cover the rest of the properties of rhombi, rectangles, and squares. On your most recent quiz, it talked about polygons, quadrilaterals, it talked about the specific properties of parallelograms. So I've put up the parallelogram side of the flowchart. Remember, our other special quadrilaterals are trapezoids and kites, and we're going to talk about those next week. But in this video specifically, we're going to talk about rectangles, rhombi, and squares. So on the quiz, as I said, we looked at parallelograms and their special properties. We found out that opposite sides were congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So we know that every single parallelogram has those properties. The first type of figure we're going to look at are rectangles. Now we know that rectangles are a type of parallelogram. So every one of these properties is going to be inside of a rectangle as well. But a rectangle also has additional properties for it. So let's look at the definition of a rectangle. We learned last week that a rectangle is an equiangular quadrilateral, meaning it has 4 right angles. So the first thing I always do when I know I have a rectangle is go ahead and mark the angles as right angles. Now we know it's a parallelogram, but let's think about why or why not. We know it is a parallelogram, so we're going to say figure out why it is a parallelogram. Well, we know by looking at it that opposite angles are congruent, which we know is a feature of a parallelogram. Remember in 6.3 we looked at our test for parallelograms. If a quadrilateral had any of those 4 properties of a parallelogram, then it proved to be a parallelogram. So we know opposite angles are congruent. We also know consecutive angles are supplementary. That's how we know that a rectangle is a parallelogram. So other things we're going to know about a rectangle because it is a parallelogram. We know that opposite sides are going to be congruent. We also know that if we drew the diagonals, they would bisect each other because that's a feature of parallelograms. Now, in addition to those parallelogram properties, rectangles have an additional special property. The diagonals are going to be congruent to each other. Now we know that they're bisected because of the fact that a rectangle is a parallelogram, but they are also going to be congruent to each other. So we want to think about why is that true? Well, think about the Pythagorean theorem. Think about this as a right angle. This is a right angle. This is a right angle, and this is a right angle. So if we have in this pair okay, I paused the video so I could go ahead and construct these and not waste a lot of time trying to construct the triangles. So in this rectangle, I've got lots of triangles, but I'm going to look specifically at this one and this one. Okay, that's my green triangle. That's my yellow triangle. And I'm going to put my appropriate markings. I know that's a right angle. I know that's a right angle. I know these 2 sides are congruent. Okay, that's those 2 pieces there. Remember, opposite sides on a parallelogram are congruent to each other. I also know they share this side. That's this piece here. Okay? Well, think about what we use in a right triangle to find the third side. Pythagorean theorem. We also know from our congruent triangles that this yellow triangle and this green triangle are congruent because of the side angle side congruence theorem. And that automatically tells you that this piece and this piece have to be congruent, and those are the diagonals on a rectangle. Okay, so let's look at how we can apply this property of rectangles. So in this first example problem, I've got that this angle right here is 50 degrees. Well, what did I say I always do when I have a rectangle, sorry. That angle is a right angle, which means this angle has to be 40. Well, let's mark all the other angles that would be either 50 or 40. Well, I know these are parallel, so those have to be the same. So that means this one is 50 because 40 plus 50 equals 90. Well, I also know that this is 40. And think about why. What do we know about the diagonals on a rectangle? We know they are congruent and bisected. So what kind of triangles are these two triangles right here? They are congruent isosceles triangles. So that means that one is 40 also. Now let's look at the other two triangles. You've got this one and this one. Well, those are also isosceles congruent triangles. If this one is 50, this one's 50, this one's 50, that one's 50. Well, how can we find the inside pieces? Well, what do all the interior angles of a triangle add to? 180. So 40 plus 40 is 80. 180 minus 80 is 100. Those are vertical angles. 100 plus 80 gives me 180 because these two are a linear pair. And this one has to be 80 also. Now, if I'm going too quick through any of these examples, remember it's a video. You can pause it, you can rewind, you can rewatch. I recommend doing that as much as you need to until you understand these properties. Now, the other property I'm going to look at is the fact that the diagonals are congruent and they are bisected. That's going to help me find specific lengths. Okay, I know all those pieces are the same, which means this is 13, this is 13, and this is 13. Well, I also know that's 10, and I need to figure out how can I find this piece right here. Well, remember, we have right triangles throughout this rectangle. So if I look at this whole triangle right here, then I realize that does not look like a right triangle. I didn't do a great job with that. Okay, so you've got this right triangle. I'm going to label that 10. Well, the hypotenuse is this whole piece right here. 13 and 13 gives me 26. Well, how can I find this length? You have a right triangle. You can use Pythagorean theorem. If I plug this in, 26 squared minus 10 squared is going to give me 576. And when I take the square root of both sides, x is 24. That means this is 24 and this is 24 because opposite sides on a parallelogram are congruent. Okay, next we're going to look at rhombi. Remember, rhombi and rectangles, the only thing that's similar about those is that they are parallelograms. When we bring those together, we're going to get a square, but we'll look at that in a minute. So a rhombus is going to have all of these special properties of a parallelogram because we know it fits under the category of a parallelogram. So anytime I have a rhombus, I can mark opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals bisecting each other. Well, as we're going to see, rhombus, just like a rectangle, is going to have special characteristics that only apply to a rhombus. So let's go back and talk about our definition of a rhombus. A rhombus is an equilateral quadrilateral, which means all of the sides are always going to be the same. So let's look at why it is a parallelogram. We know that if a quadrilateral has opposite sides congruent, it automatically makes it a parallelogram. And that is the case. They are all congruent to each other, but that also means that the opposite sides are congruent, which is what makes it a parallelogram. So, special properties of a rhombus. First thing is that the diagonals are perpendicular, meaning where they cross forms a right angle, which means all 4 of those angles are right angles. Think about what we use when we have right triangles, Pythagorean theorem. Just like in the rectangle, we had to use Pythagorean theorem to find certain things. We're going to do that in a rhombus as well. The other thing that's special about a rhombus is the diagonals bisect the interior angles. What that means is that's bisected, meaning those 2 pieces are congruent. But what do I know about opposite angles in a parallelogram? They are congruent. So that means all 4 of those angles are going to be the same. And if I look at the other pair of opposite angles, those are congruent because it's a rhombus and they're bisected. And they're also going to be congruent to those. So you have many congruent angles inside of a rhombus when you draw the diagonals. Now, just like we did before, we could look at our properties of a parallelogram and prove the triangles are congruent to prove why the diagonals are bisected. For sake of time in this video and to make sure I show you how we're going to use these, I'm not going to go over that. We can go over that when I return next week if any of you specifically want to see that. So let's look at the special properties of a rhombus and how we use these. We said diagonals are perpendicular, so I'm going to go ahead and mark that as a right angle, just in case I need it. But I also know the diagonals are bisected, which means all 4 of those are the same because of the fact that opposite angles in a parallelogram are congruent. So that means that's 40, that's 40, that's 40 degrees. Well, how can I find the other pair of opposite angles? Well, think about that as a right triangle. What do the interior angles of a triangle add to? 180 degrees. Which means if this is 40 and this is 90, then this one has to be 50 because they all have to add to get 180. Well, I know all of those are the same, so these are all 50 also. Now, we can also use our special properties to help us find side lengths. Okay, I know it's a rhombus. I know that makes a right angle. They have told me that AC is 10, which is this whole diagonal. Well, because it's a parallelogram, I know that the diagonal is bisected, which means that's 5 and that's 5. Well, how can I find the other sides? First of all, if you think about it, it's a rhombus. That means all the side lengths are the same. So all of these, all the side lengths are 13. Well, again, we go back to the fact of what kind of triangle is that? It's a right triangle. What do we use to find a missing side when given 2 sides in a right triangle? The Pythagorean theorem. So if I plug that in, then 13 squared is 169, minus 5 squared, which is 25, gives you 144. And the square root of 144 is 12. Okay, this is obviously not drawn to scale. Many times your figures are not going to be drawn to scale. I would say most of the time they're not drawn to scale. But that doesn't matter. We can still find our information. Okay, so that's it for the features of a rectangle and a rhombus. On the next video, I'm going to go over squares. I have a time limit on these videos. So just go to part 2 of the video to take notes on properties of a square.